Hello everyone, welcome to the third GDG tutorial of this semester. Today we'll be talking a bit about coding, and especially C# coding, as that's what will be used in Unity. I hope you've all had a hopefully not so stressful week this week, especially as we prepare for mid-semester break. But without further ado, let's get into the tutorial. Alright, so first of all, an overview. C# is pretty involved in the non-editor side of things, surprisingly. Just like art or music. So I'll also cover some useful links as well, and split the coding into the C# by itself, as well as Unity scripting, the workflow. As always, if there's any questions or queries, go to one of us in the social media accounts. The learning materials, including these slides, are in the Drive link shown above. They will also be posted in our social media chats. Now, the schedule is slightly different this time around. Of course, this tutorial today at the 3rd of September. But we'll also would like to give a special announcement for the annual general meeting of our very own club. That will be held in 12th Saturday of September. That's next week Saturday, I believe. So if you'd like to voice opinion, share some memes, or even share, screen share some games, or hell, even become an executive, you can. Just go to the AGM and all will be revealed. Now, for semester 2 tutorial content, I'll repeat again. Tutorial 1 will be foundations, as we've done. Yep, this is basically the same as last week. So for this tutorial, things are, of course, once again a little bit different. I'll use the tutorial freeze scripts to give examples of code that we did for the actual tutorial itself. And then we'll build upon, the C# basics and stuff. And apologies if you can hear, but my dad is for some reason deciding to vacuum at this moment, so please ignore that. Okay, onto the useful links. Let's see. One of the biggest problems when it comes to coding is errors and frustration and hair-wrenching pain and desolation. But the key thing to remember for coding is, first of all, don't let it stress you out too much. Definitely know how to get help, and to assist that, you ideally want to learn the terms used for, whenever error messages pop up, so you know what they're referring to. There's nothing worse than not knowing how to get help when you're confused of the terminology itself. Okay, so take a break, Google your error messages. We'll give you some links on the typical places people look for help. Learn any unknown terms, debug.log, or get a sample scene from Unity API. Sample scenes let you also tweak the values of the sample, so you could, if you so wanted to, you could actually copy and paste into your own game if it's relevant. But yeah, debug log is a print statement, and print statements tell you what's happening inside your code. So instead of just guessing around, you can actually see what a value of a variable is. This is more for VS Code users, because in Visual Studio Community Edition, which is the full IDE, you can actually measure the values without having to use debug.log. On the right here, we have a very, very common situation. You try to do something, you do some changes, you realize that, oh look, there's a no reference exception. That is a big oof for every programmer. Everyone has experienced it before. But if you're getting frustrated and can't find where the source of the error is, simply look in Stack Overflow. This page gives you a good example. What is a no reference exception and how do I fix it? This doesn't just apply to Unity, this also applies to everything in like every language ever. Stack Overflow. So to go more into the useful links, there's the Unity documentation, the manual, concepts. The scripting API gives details on bits of Unity and how to use them, i.e. methods, and what types go into and out of a method. Unity knowledge, even intermediate level Unity users would still be referring to this a lot. Actually, I'm pretty sure all Unity programmers will eventually be using this a lot, the scripting reference, because it tells you, well, how to use Unity itself. In fact, I'll give a quick example right now. So this is an example of the Unity scripting reference. You can see here it stands for C#, because Unity only used C#. Back then they used to also use JavaScript, but they deprecated that, so don't worry about using JavaScript, basically. On the left side here, you can change the version. In this case, you want 2018.1, and I suspect if you guys have been following the previous slides, you will have this version as well. Go to the version that's correct for your Unity. And here, you can search, for example, get component. This is a very common method. Everyone who's making games in Unity will get across this sometime sooner or later. So may as well break the ice now. Game object dot. These ones are relevant. You want to get. Let's see. Get component. Get components. Oh, this one. So this is an example of GameObject.getComponent. I'll get into this a bit later, the switch to manual button. But basically, in this scripting API page, you can tell that it gives a component and it takes in a type. Now this is the old-fashioned way of doing it. This is, I believe, the modern way of doing it. So what you do is get component and then whatever type. You learn a bit about types later, but this is how you access scripts and stuff inside a game object. Now, clicking switch to manual brings you to a manual description of everything, and here's a very, very simple explanation of what game objects are and what they do. This section over here is pretty important. The transform component basically tells you where the game object is. If you want to move a game object, or anything for that matter, if it's a game object, it has to transform, or there's actually another special type for user interface called rect transform, but I won't cover that yet. Transform, so position, rotation, scale. Okay, back to the slides. Okay, so that's Unity documentation on the left there. In the middle, you'll see, there's Stack Overflow here, which I mentioned earlier. They mention everything, and not just coding too. They also give like world building tips, or history, English grammar if you so desire. Also up here is Unity forums. Basically, game devs helping game devs. Is this important note here? If there's a pop-up saying you need to log in or sign up, just ignore it by using incognito mode. Honestly, that is just pretty scummy, but incognito mode just prevents them from doing that to you. On the right here, I should put this on left because it's beginner stuff, but basically C# tutorials give you a good intro into coding in general and C#. So I'm assuming like at least a third of you know coding. So I won't cover this in much detail, but if you just begin coding, C# tutorials is really good, and there's even an interactive browser that lets you learn the concepts up there. However, I should stress that some of the code isn't exactly the same in Unity. For example, console.writeLine instead is debug.log in Unity. So this is Microsoft's tutorial debug statement, or C# in general, and this is Unity's. In fact, let's take a look. Okay, so this is C# tutorials. As is tradition in programming, Hello World is your first thing that you usually learn in C# tutorials. I'll just briefly skim over this. Interactive lessons that you can run in your browser. Yeah, so these first three is pretty relevant. List is not as common as the other three, but it's good if you want to have like lots of different items sorted at once. Then you use loops for the list instead of arrays, because lists can expand dynamically. There's more a tip for those who are moving from other languages and already know programming language. Okay, and this is just, you know, this is probably not necessary. This may be useful, but yeah. And here you also find C# concepts, basic types, very useful. Yeah, okay, back to your slides. Alright, so I'll go over what I mentioned earlier. So C#, this is lots of mumbo jumbo from the Wikipedia page. It's definitely not conducive to learning. Type decoration. This is basically means that, as I was probably saying with a muted microphone actually, that the type has to be declared at the beginning, and you can't dynamically change the type after you initialize it without casting. So casting is very important to change from one type to another, and otherwise it'll throw up an error if you try to force, say, a transform to be a game object or vice versa. Now, memory safety is very important, usually in every other language that doesn't do memory management, but like Java, C# is memory managed, so you don't have to worry about arrays or pointers. You could just safely dispose of them once the array has been fully utilized and you don't need it anymore. Each script is equal to a class. So basically what that means is within each script you have methods and parameters, although for simplicity's sake I'll just say the values data within the script. Since C# is a class-focused language, they say it's object-oriented programming, where you could create a type of a script, and then that's how you control things by calling the methods in said instance, copy of a script. Dot notation here. This is more for the complete coding beginners. Game object calls get component, and then get component is a sorry, get component is a method that takes in the type of hinge joint. And then what happens in the statement is you perform right to left. So you know that it's trying to get a component of type hinge joint within this game object. That's essentially what this line of code is saying. Now, very similar to Java, as mentioning earlier. The syntax is also pretty similar as well. However, instead of being wordy like Java is, there's it uses a few more symbols too, like this, the colon for implements or throws. Sorry, not throws. As For tutorials, one important idea in coding is reusability, not overly repeating yourself when writing code. By planning ahead, you can prevent writing the same or similar code, and you don't have to expose yourself to the risk of typos, as well as saving you time from writing the same lines multiple times. The simple rule of thumb is, as usually mentioned in classes, is if you think you'll repeat it 3 or more times, make a function and write it. Call it 3 times instead, or more. Now, I'm only mentioning this concept earlier than the others is because it applies to tutorials too. Unity Learn C# Survival Guide is a great resource, and the Microsoft C# tutorials I mentioned earlier, that's a great resource too. Okay, Unity scripting. Now, this screen on the right will be familiar to you, to those who've seen tutorial 1 and remember. This is an overview of the editor window when you log into Unity and open up the executable. I just want to briefly bring this up so I can mention the 3 parts. Hierarchy window on the left side, inspector window on the right side, and project window in the bottom middle. Everything in the hierarchy window is a game object. Everything in the inspector window is a component, and the project window has assets. Now, when making a game, you initially start by dragging things in by either File Explorer or some sort of package manager. That means you bring in assets to the game. You realize that assets have this .meta file which tells you like the import settings and stuff. If you remember from the sprite settings task that we did last tutorial. The stuff in the project window includes things like scripts, music files, art, materials, textures, scenes, and other stuff like that. Basically, the game uses the assets to make duplicates of, called instances. Instead of changing the actual asset, it makes instances and changes the instances values instead. And then you make things bigger or larger, or different colored, or different sprites, all in the scene view and inspector window. The reason why the instance and actual distinction is important is changing the stuff in the scene view doesn't change what happens to the project window. And this is a key point to know in coding. As whenever you make an instance, you don't have to worry about accidentally damaging the original stuff. A component is basically one of these things here, i.e. the transform. If you saw that earlier, I don't know if that was showing in the black screen, but yeah, a transform is a component of a game object, and it's in basically almost all game objects. Describes the position, the rotation, and the scale of the game object. Scripts themselves are also a component, so that's one way of inputting it, by dragging the script from here to here. Now, as I mentioned, I'll reiterate again. You make a script, do whatever code you do in your IDE or editor that you use, and then you drag it into either hierarchy window or into the inspector window directly. And then you see the script pop up here. Now, there's this thing called public-private keyword in coding. Basically, it means that if it's public, you can see it from the inspector. If it's private, you can't. Public variables can also be used by other scripts, and you could change it in the inspector to allow artists or non-coders to design the game easier and change script parameters. Okay, on to tutorial. So we're going to cover the PowerPoint. Those of you who were here last semester may remember this, but this is an instance of reusability. In this tutorial, we'll teach the basic types and an overview of Unity's execution cycle. Okay, so this PowerPoint is also found in the Unity drive called Coding the Digitized Language. So, previous tutorials made you drag and drop pre-made assets into the right places. For example, the boundaries, the player, the enemy robot. That was the first tutorial. And the second tutorial, there's sprites, animations. Basically, it's to familiarize yourself with how you drag stuff into Unity and using the drag and drop functions. I didn't focus too much on the code. It does bog educators down a lot, and that's why this tutorial will split into the basics of C# as well as the Unity side of things, probably in the next tutorial, where we'll cover it practically a very short section. Okay. So C# uses methods to pass values to each other using dot notations, hot potatoes. Otherwise, the syntax is the same as other C languages. I will repeat that you need to declare variable types in C# because else they'll throw a huge error and spit in your face, basically. Now, C# is a high-level language. That basically means it's good for programming in and fast to do big changes and stuff, but it's not very performant. So Unity actually converts the C# code into C++ through some hidden technological magic. This essentially combines the productivity of C# with the cross-platform compatibility and speed of C++. Now, some quick overview of the basic fundamental variable types. These are the primitives. There's string. You initialize these in double apostrophes. There's boolean, which only have two values, true or false. Ignore the double apostrophes in these examples. Actually, yeah. Just ignore the double apostrophes in general. It's only used for initializing in the strings. Otherwise, it's just for notifying when a specific example is used. Okay, so true is one of the two values of Boolean. If you're familiar with Boolean algebra from computer systems or computer science, then you can flip it around by using the exclamation not operator. Integer, that's like your whole numbers, 1, 2, 3, 0, -1. Also very useful for accessing arrays. There's floats, decimal numbers. They cover the entire real number spectrum, so like 1.5, like 1.2, etc. etc. To make a float and to separate it from doubles, which is another type of decimal number but with a different storage type, floats are appended with if. It basically tells the code, the compiler, the thing that reads the code to do stuff, that this is indeed a float and not a double. In Unity, this will be important whenever you make decimals, because it may reject your code if it doesn't exactly specify if for every decimal number. Now, in Unity, another two variables here that are very important, vector3 and vector2. So you need it basically bunches three floats together to make like a three-dimensional vector. So you use it to describe A, your position in space from origin, and B, like movements and forces and stuff. You do that with vector3s. You also need to remember to add the new operator, new keyword, in order to tell the compiler that you're making a completely new vector free and that this isn't a method or something. Yeah, since this isn't actually a primitive, but I basically treat it like one because it's so commonly used in Unity. Vector2 is the same except only in 2 dimensions, x and y. Conditionals, they're the if-else statements. Whenever there's a choice, a decision. Another staple of coding. This here's an example. With the activate is paused equals false. If activate was not true, is paused equals true. Now you should note those curly brackets in coding. This is for these following steps are for like the complete beginners in coding. The curly brackets represent method calls and casting. Sorry, the normal brackets represent method calls and typecasting. The curly brackets represent function begins and ends, and conditionals and statements, basically. Semicolons are necessary to end statements to tell the compiler, oh, this is like the end of the line, or the end of a particular statement. If you ignore one, you'll end up with a heap of errors, so if you're completely new, make sure to put semicolons at the end of each statement or line. Code in general is very picky about your spelling and stuff, so definitely up your spelling game if that's not your forte. Alternative to a if-else statement is a switch case statement. Good for simple logic checks. Now, the game engine itself is basically one big infinite loop. And by infinite loop, I mean that it basically runs non-stop until you tell it to exit. And the reason why you check, how they actually check if it exits or not is through these if statements or logic operators. Sorry. There's the for each and while loops. Those are 3 loops. And to implement the logic, use these logic operators not, and, or, and check equal, and check not equal. These are all listed in the C# documentation in Microsoft's website. I mentioned here arrays. That basically means that loops are great for doing the same things multiple times, and arrays is, what do you know, the same types in a straight line, so you can just iterate through all of them quickly and without doing the same thing like a million times. Now I'm going to return to the full screen, the browser, and enter a repo where I'll quickly show you an example of coding in a coding problem or exercise. Repo is a pretty useful online compiler or editor, something similar like that. I don't know a technical term, but basically it lets you play and compile and write code and test things, and there's even tutorials if you know what words to search. In this case, I've uploaded tutorials in a zip file on the drive called warm skeletal pattern. There's 2 ways you could go about this. Either you could enter this URL and then immediately make a fork. There's this big button on the top middle that says fork. You click that. But in the case that the repo is corrupted or something, I've made a zip folder with the same name that you could use to upload into repo.it and do the question problems like how they're intended. Okay, so to a quick overview of how this example should go. I only do like one because I won't have time otherwise. There's 6 different types of things to comment in or out. This is the main. You want to see the examples to learn, and then you want to do the questions. Alright. To comment something in or to comment or uncomment, you remove the 2 forward slashes on the left of the line. If a line is commented, it basically doesn't affect the compiler. The cog on the left hand side, open settings, and you could turn on code intelligence and use dark theme. Also large the font if you find the writing a bit too tiny. In the questions.cs files, you'll find blank functions with nothing but comments. They describe your mini task, and you'll basically solve it to proceed and learn programming. Okay. So if you've opened up repo.it from a simple Google search, this is how you make a new repository, or repo.it, to do your coding in. Simply search up C#. This is, I'm assuming, if you're downloading the archive and you want to make a fork, well, you want to make a duplicate of the questions that way. So it comes up with a randomly generated name of the URL. In this case, it's called Faraway Good Natured. Wow. In the settings, you see layout theme, it's too dark. Font size, normal. I'll do large so that you guys can see what's up. Indent size. Some people say 4 is better for Python, but it doesn't do any visual difference, as you see. Code intelligence, this is pretty useful. Okay, so if the fork the fork URL that I've listed is broken because someone changed it before forking, this is the way to copy the questions into your a new repo.it and do the questions that way. So press the 3 dots on left, upload folder, and then choose the folder that I've uploaded onto the drive. So in this example, I've already uploaded the stuff. On the left side, you see the 6 examples/questions files, and then also the main. In this case, it's showing the main.cs and this executable, which basically tells the thing to run, how to run. On the right hand side here, you see the output of the console. If you're doing this in Unity, just think of this like the console window. Okay, so in this example, I've uncommented the type examples run file, function within the type examples.cs file, which is this. Okay, you see here a lot of code, but the only ones you want to worry about is the ones where there's lots of text. If there are questions in the questions.cs file, you see something similar to this, where you put the code between the question problem and the closing bracket. So you put your solutions here. So let's just go over the examples. Let's just do one example each, because I'll also take a long time. So let's just go over the string example. As I mentioned earlier, for C#, not in Unity, console.writeLine is the thing that prints whatever you want to the editor console output. Okay, uncommenting the bool example outputs a display of the second example. So you see that a lot more things output this time. So to explain these two examples, the string example and the bool example, basically when you use console.writeLine, it takes in a string within the curly brackets, and then outputs it to the console. In Unity, that will be used debug.log to take in a string to output to the console window. To declare a type, for you who are just beginning with coding, you first put in the type of the variable and then the name of the variable you want to create. Assigning variables, you use the equal sign, just a single equal sign here. It basically means that you're turning it, you're assigning a value to this variable, in this case hello. Now you can create another one and assign at the same time by using string message2 equals world. You can also join strings by using the plus. So in this case, this is just an empty space here. Message plus space plus message2. And then I'm writing it to console output. Hence the hello world. Okay. Again, the console write line with an empty input just outputs the empty line. For Boolean example, Booleans, as you remember, only has true or false. In this case, fact is true, fake news is true. The value of fact equals fact.toString. If you ever want to print that's something that's not a string, you have to use the toString function. That basically converts it to string if you can. Usually variables you make don't have the capability to transform to toString, but the ones that are already pre-made, like vectors or floats, they tend to have toString available to them. Actually very few functions. Only the very common functions have toString. Usually you have to like say, oh, I want the name of something to find out what exactly the thing that you wanted to find was. In this case, I'm outputting the value of fact is fact.toString. The value of the fake news variable is, they're both true because I didn't change them. So let's just say that, I made this function that gives the opposite of fact. This essentially, you can't see here, well actually you can, it's down here. Result equals negative b. Using the not operator, it transforms this fact from true to false. Remember, fact is a variable, and I've changed the value of the variable from true to false. There's this another variable here that goes result equals not b. This is pretty important because variable changes in Bool example affect this, but not the other way around. So basically it means that things that happen in the functions don't affect the things in the thing. Sorry, the things that happen in a function don't affect the function that called the subfunction. That may sound confusing, but it means that things that changed and changed this far doesn't affect Bool example. So, okay, after this line, we know that fact is false. If you printed it, it will be as the same as before, which is false. Now, if you wanted to change, since you're passing in a variable, boolean b, if you want to print the result of not b, it will say it's true. However, if you were to print it after the called function, you'll find that it remains false. And that's just saying that what happens inside a subfunction doesn't affect the main function. That's a topic called scope, which is pretty useful for separating things of the same name on different levels, but mainly to perform operations on functions without affecting it. Alright, explaining all this will get pretty wordy, so I'll just leave it to you guys to figure it out, because it's pretty simple stuff. All the explanation and tips is solved inside the comments. If there's any questions, you look up MS C# documents, because those will explain everything super easily. I'm not actually sure if this could be simplified any further, but yeah. So a simple question here. If you want to do a question to test your knowledge, comment out the examples function and the script, and uncomment the test function within the type question script. Now let's see. Basically, it's saying on the right here, int function, bool function. So this is one of the free question files. You have to solve them using your own logic. So this string function here. Oh, this is a typo. This should be boolean. So declare engine131 in the console. Okay, so remember from the previous file that console.writeLine is actually what prints to the console output. So there we go. We'll just copy this string Where is it? Ah, right. I probably overwritten it. That's probably why reason why it doesn't show up. But we'll ignore this for now. That was a pretty simple one. Boolean function takes 2 booleans and outputs a boolean. In this case, this question is testing your knowledge of passing in parameters and returning parameters, because this function takes in 2 booleans and it wants to return only the second one. So to do that simply, you just go return B. Now this is the previous output. You can see that only scored 2 out of 4. But if I run it now, 4 out of 4. That means you scored perfectly for this one. And that was a pretty simple question. Alright, so the others are similar in that test your knowledge by putting in code here, usually in the return value. If the logic you've written was correct, then you score 100%. Okay, so there's also another examples for conditionals. For example, the if statement and the switch case, and the loop has examples for the array example, while loop, and there's a for loop as well. As mentioned earlier, if you want to see different examples, you just uncomment and comment. Okay, we'll get back to the slides. The C# tutorials, as I've displayed on the screen, great for learning the basic concepts if you want to go more in depth into this. Alternatively, you can always just ask us for help, and we'll go help as soon as possible. Okay, that's the C# stuff done. Now let's talk about Unity itself. Game engines, one giant loop. The frame rate isn't as easily changed as it is for the player. We have to actually manually optimize things. But in Unity, it's usually set to 60 or somewhere between 60 and 30 FPS. The reason why things happen in games is because they animate or physics updates things to move a bit over time, and it usually does this very often, each step of the game loop, and that's what makes it seem like it's real time. It looks like it's continuous, but it's actually discrete, but fast enough so your eyes don't notice that it's not continuous. So if you recall from scripting, looking at the scripts in the code, update is the main repeating function, which happens once per frame. And there's 60 frames in a second, so give or take a few depending on your computer performance or logic. However, we also have to consider the fact that graphics and stuff is also rendered, because when exactly does the game take the time to, put stuff on screen, draw triangles, calculate physics? Well, it does that off screen, like you don't even see it. For simple Unity stuff, you don't even have to worry about that stuff at all. And that's because Unity makes it super easy for people to script by using these magic functions like update or start. Rendering is all handled elsewhere unless you are really pushing for performance or extremely high quality displays or demos, then you don't need to worry about but unless you do those, then you don't need to worry about the rendering at all. Game engines run super fast, but that's because modern processors themselves are super duper fast, and only if you do some huge as calculation does things even begin to slow down. As you can see, start and update are only two functions in this giant loop over here. This giant loop, I can't even show over on screen without the text being too tiny. Basically, it's how Unity goes through all the logic and all the rendering passes and all the internal physics and etc until you basically tell Unity to quit. It does this infinitely. Alright, so the most important functions really for a beginner or if you're just starting out Unity to learn is start, fixed update, and update. Update, as I told you, runs 1 frame per second, 16.7 milliseconds. That's super duper fast. If you see a game slow down, it's probably because you're putting in too much stuff in there, loading into scenes, or your logic is in an infinite while loop, or is just doing really unoptimized logic. But we'll worry about optimization for way later. Start, only code once for a given script. That's where you initialize values, position things, do all the heavy stuff that could be done on initialization, so you don't lag the infinite loop whenever it runs update. Here's fixed update, good for physics if you don't want to worry about time differences between different spec computers. Usually use physics. So as I mentioned earlier, start is used for caching game objects. To cache means to basically to assign the variable into, assign a value into a variable that's instantiated, so you don't have to keep on assigning it. Because every time you assign a variable, it takes up time and memory that could be used. It could take up processing power that could be used elsewhere. Also, for huge functions that you don't want to continuously repeat over and over, if you could do it in the start, it's usually better too. So yeah, these are all pretty self-explanatory. Something I should mention is game inputs like keys or mouse button or your numpad or whatever. They're usually done in update, because update runs usually faster than fixed update, because update isn't linked to your physics checks. Examples of event functions. Event functions, magic functions, they're the same name. Mouse click. So this one's a very simple one. It's an if statement here, and the rest of the code is hidden. But basically, if you input duck a button down fire 1, it fires something. It's a simple example of a conditional. Oh. Thanks. Down here in define script here, there's the start function calling initialize card thing. All this super complicated jazz is initialized in start, so you don't have to worry about all the costly performance hit that this would do if this was happening every frame. Game objects contain components, as I mentioned earlier, manipulated with code. This here is a basic, super duper basic movement script for a player, or, well, more like a square to be honest. And that's by adding forces in the direction that you want. Oh, this is already getting a bit too long, so I'll probably speed it up. This here is, oh, this is the second last slide. This is the classes. Abstracting so classes. You create instances from it. Each script is a class, as you remember earlier. And this is a pretty difficult to explain, but each instance is that you change the value without altering the original class itself. Classes are methods, you use it to manipulate data. And get component is how you access scripts or rigid bodies or sprite renderers of a tree, for example. This here is the script. It's an instance of a class the same name as the script. To access a script from another script, you either access the public variables with a reference, or you get the attached game object, the attached component within the game object, and then use get component. You may hear type and class used interchangeably a lot, and there is a subtle difference, but most people probably don't need to worry about it until you get to like the more advanced topics. And I'll give a quick shout out again to the scripting API. If you really wanted to read things before doing it, although it's usually better to do things so you learn better. If you really wanted to read the stuff before scripting, or if you're particularly lost, I suggest you read the things here highlighted in red arrows. So, scripting overview, order of execution, shown earlier, generic functions, and this extremely notorious error called the no reference exception. And the vector cookbook as well. So this here's another example. If you see a value assigned inside the API's description of the method call, then it means it's optional, so you don't have to put it in when you call it. But yeah, that's this slide done. But you're here to see the Unity in action. I'll just give two quick presentations here. Two quick scripts. That is the activate script and the player move script. The player move script is pretty complicated, but the activate script should pretty simply explain what I'm trying to teach here regarding Unity scripting. Okay. So in Unity, I'll just go and click on activate, and I'll open up a VS Code screen. So this here is the activate script. We use it whenever we want to transition to another scene. This is relatively simple. The other scripts are certainly way more involved than this, but this script covers many things that I'd like to portray. First of all, it is the start functions. There's no update function because I don't need to use it. So this very simply says if the thing that needs to be activated is not unlocked, then you lock the door. Otherwise, you unlock the door. This is an example of a function. So putting this in is actually referring to this function over here. So at the start of the script, it starts this, and then it goes here. If it's unlocked, not unlocked I should say, due to a not operator, it locks the door. So it runs this. Ignore the virtual, it's a pretty advanced topic. But basically this line here says, oh, in this transform, static transform, this is a method, we want to find something called a door sparkle. In this case, that's the sparkly animation that you see in front of every door, the star, or glitter animation. Once I have found it, get the game object, and I want to call this setActive method on the game object. In this case, the set method, as you see on screen, says activates or deactivates the object, and it has a boolean input, so false. That means we set the transform.find door sparkles game object false, basically turning it off. And then it'll set the variable unlocked false. Now this example doesn't have commenting, but some of the other scripts do, and if you want to snoop around, feel free to. You'll find the tutorial scripts, of course, in the previous tutorials folders. This one is also another pretty useful one, on trigger stay 2D. Basically, this is one of the event functions, or magic, well, could be called magic functions, but not as magic as this. The on trigger stay basically means that whenever a collider, which is a component like a hitbox, comes across another collider, and both of these colliders, the other collider is triggered, so hitboxes can be made triggers instead of just reacting with physics. Whenever you stay, for each frame, you play this function. So on each frame, if the game object is a player, and the input, if the player presses jump, then you activate the object. And this activate object currently does nothing, but it basically gets used in other scripts to do some fancy things. Okay, these are two pretty simple examples. Now let's go to something a bit more, well, relevant to jumping or platformers, or basically any game really. Player moving. Now this looks pretty complicated, and certainly more complicated than I like to teach, but the important thing here is the move function and of course the update. So if you remember correctly, update is running every frame. It calls move every frame. In this case, move sets the force speed to 0f, and it lets you fast forward by pressing the down arrow key. Input.getAxis basically detects when you press the down arrow key, as was the same for activate. Input.get button down. Axis in this case represents the arrow key. So this is for a simple platformer that lets you fall faster when you press the bottom, the down arrow. For moving, it will create a new vector 2, and as you call vector 2 takes in the x axis. It will show here if I highlight it. Put my cursor over it. Float x, float y. A new vector with given xy components. We want to change the player character to move in a certain direction by pressing left or right. If it's in the air, it will fall faster if you press down. So for left and right, we'll use this input for left and right keys, horizontal, and we use force speed to, as we said here earlier, make it fall faster. This is assigned to a vector 2 called move input, and this is assigned up there, but this basically means a rigid body. This is what the physics are affected on a character or player. We want to change the velocity to plus equal. That means velocity plus speed plus move, speed times move input, and then assign it back to itself. You also may see a minus equals, but that basically represents rb.velocity. This is equivalent to plus equal. So if I add speed, which is defined above, times this move input vector 2, I can move the rigid body and the player itself whatever velocity I want, whether left or right. This move function within the update function is just a very simple example of movement. Usually you can either do two things when it comes to player movement: tweak the physics, which I've done here with the rigid body, or like manually translate the transform of the game object itself, of the player itself. That's a bit more involved coding wise, but it does give you some interesting interactions or behaviors. For the jumping, there's the is grounded equals check grounded. I won't go into details of this function, but basically it checks whether it is ground on the feet. If it's grounded and the player jumps, jump equals true, and jump. Basically add a force pushing it upwards. If you're already flying in the air, you can't jump again. This isn't one of those double jumping games, unfortunately. So you'd continue falling. Now, since every 2D game has to worry about sprite direction, you don't want to move in the opposite direction you're facing. So there's this function here called set sprite direction. It takes in the transform's local scale as a vector 3. If the velocity of the player is moving left, which is negative, then flip the scale so it's negative, i.e. invert the sprite and the character itself on the on the vertical axis so it's facing left. Mass.absolute entity scale. Else if the character is facing right, then it moves with the sprite facing the original direction. So with the sprite facing right. This assigns the variable we've just made, because remember, the function doesn't affect the variable that's given into it. So we have to assign it into the transforms component's local scale. Alright, and this sets the sprite direction. This is player movement in a nutshell. And yeah. Okay, and that's it for a tutorial. This was pretty involved. I apologize for the black screen at the beginning there. Technical difficulties. But if you have any questions for the repro.it, I encourage you to go to one of our student social media sites, and ask us. Credits to the same assets as previous tutorials for the pixel art and stuff. And that's it. Like, as a reminder, the AGM is 12th of September, so if you want to voice your opinions or get in touch or help out with GDG or many other things like projects, you could give us a shout at the AGM. So, where is it? Here it is. Okay, 12th of September. And
I gotta believe.